Corporate finance practice problem using OneNote. We're going to be using an annuity calculation to find the interest rate. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you have access and would like to, we're in the tab on the left-hand side. We're down here in the practice problems, and then in the 944 use annuity calculation to find interest rate tab. Also note that when using OneNote, you might want to take a look at the immersive reader. Many of our presentations will also be repeated down here with the same number in the text files being in essence transcripts of the presentation, transcripts that can then be translated into multiple different languages and both read or listened to in multiple different languages, thereby being a good complement to the practice files up top. Closing this back out, we're going to have our information up top. We'll then calculate down below in the blue area, and we'll do that calculation in a few different ways. So here is our scenario up top. We have the invest 60,000. We have the payments of 5,500 years 20. We're looking for the interest rate. Now, basically, we have the information for the present value of an annuity type of formula, with the rate being the unknown as opposed to basically the initial investment. In other words, if you think about the normal kind of situation where you'd be solving for the how much to invest, like the 60,000, the question might look something like this. You'd be asking, well, if I was to want to receive in retirement the 5,500 in an annuity per period per year for 20 periods, then typically I would have to assume an interest rate, present value that in order to think about what the initial investment would be in order for me to set up that annuity, thereby solving for the 60,000. You could end up with a situation, in this case, we're saying, well, we know what the investment is, 60,000. Possibly we're imagining talking into like an investment firm that says, yeah, if you give us the 60,000, we'll pay you 5,500 for 20 years. And they just don't give you the interest rate in that case, right? And then we'd have to say, okay, now we could figure out the interest rate if those are the conditions. And we can use our present value of an annuity formula to do that, which would be the end result would be the 60,000. So 60,000 would then equal P. P is going to be the 5,500 times 1 minus 1 plus R. R is the unknown. And that's going to be to the negative n number of periods. That's going to be the 20 in years in our case, divided by R, once again, the unknown, thereby having R as the one unknown in the equation, and then we could solve for it algebraically. So that's probably what the primary scenario would be if you're doing a book problem. In practice, however, it's most likely that we would be using present value functions within Excel, and we would probably want to think, well, how can I use the present value function to basically solve for this problem? So note, mathematically, what you would do is you're not going to create a new equation for R. I'm not going to memorize an equation in case I get a question like this that then is solving for R. No, I'm going to use this same equation, hopefully being able to recognize that I can fit this information into a present value of an annuity formula and then solve for the unknown R, so I don't have to memorize another equation. But if it's a function, then it's a little bit more difficult to do that. If I scroll down here, if you go into Excel, you're going to say, hey, look, I want to use this present value formula. That's what I know. And can't I use the same kind of theory, meaning I know what the end result should be, the 60,000, and I know the number of periods and the payment. The only thing I don't know is the rate. Can I use this same function in order to solve for the rate, or do I need another function? Because I can't do my algebra here. I can't take this function and algebraically solve for the unknown of the rate, and we'll think about how we can use that same kind of function to do a similar process as with the algebra, solving for the unknown using a feature called goal seek, which is in Excel. We do this in Excel as well, so you might want to check this out in Excel as well. So first method, we do it algebraically. Second method, we do it basically with a spreadsheet and solve for the unknown in the spreadsheet. So if I take this formula and I statically put it into basically a spreadsheet, and without reworking it algebraically to solve for R, I'm just going to put the normal formula in place and then think about how we could basically use trial and error, which is in essence what goal seek is, to find the unknown amount. So to do that, I'm going to put this into our little worksheet down here. I'm going to put the P on the right-hand side. That's going to be the 5,500. Then the numerator is 1, so I'm going to put the 1 here. And then we're going to say 1 plus R to the negative n. I'm going to pull that into the inside. So here's the 1 plus the R, 6.63. Now, if we didn't know what R was, then what we would do is put in some number here. So I would put some number in. I wouldn't put 0 in, because some functions, if it's division by 0, for example, will come up with a problem. So I want to put some number there. I put like 5 or something like there to start with. This is actually the answer, but if you were using this method, you'd put something as a starting point like 5, and then you would add this up. So 1 plus 6.63 would be the 106.6, taking this to the power of 20, because that's the number of periods. We then get this amount. Then we can subtract. That's going to be the entire numerator. 1 minus that amount, giving us this 0.7228345. That's the numerator. Then we would divide by the denominator, which I'm just going to use the same number as this number. So if I had plugged in 5 here, I would plug in 5 here just to work the problem. And then we're going to divide this out. Numerator divided by the denominator gives us this item here. And finally, we can multiply P times the whole thing that we have now calculated, 5,500 times this whole thing. That gives us the 60,000, because we have the answer correctly here at the 6.63. But once again, if this was the unknown, if you just plug in some number there because you don't know what that is, then you can imagine you can use trial and error and recalculate this number. If it was 5, you could try 6, and then try 7, and then narrow it down between 6 and 7, and so on and so forth. That would be tedious to do if we did it mathematically. If I pulled out my trusty calculator and did that mathematically, that would take me far longer than it would simply to solve for the equation, reworking it algebraically, solving for R. But if you have a spreadsheet that's all tied together with formulas, that is easy to do. I can change this number, I can run different scenarios with it because it's all connected, and I can ask Excel to do that. Excel then calculating it with something called goal seek, meaning I could tell Excel to set this amount to what we need it to be, 60,000, by changing then the unknown, this amount, and allow Excel to use that trial and error method to back into the unknown without us even having to change the format of the equation in essence. Now, this is probably not something we would do so much with an Excel worksheet like this unless we set the formula up in an Excel worksheet. We're not, once set up in an Excel worksheet, the point of the Excel worksheet is that we can plug the numbers in. We're probably not going to rework the algebra here. We could rework the algebra if it was set up, obviously, as just writing down in an equation. But this leads us into what we can do with the Excel function. So if I go to the Excel function down here, now this is what would most likely be used in practice. I probably wouldn't be calculating it by hand in practice. I'd be saying, hey, I just used the present value formula. Normally, if you ask someone who works with present value formulas, they probably don't know the equation at all, right? They just use the present value formulas, and they're going to say, well, now I want to back into the interest rate here with this present value formula. Can't do it algebraically, but can I use the same algebraic concept to find the unknown other than the end result of the present value calculation? Or do I need to find some other function that solves for R, which may be there, but it's far less common than the present value calculation? So we can then do the same thing. I can plug this number into some other cell in Excel and tell Excel to rely on that number to form the calculation. I will not make it 0, because if there's something in the function that results in the function being NA, not applicable, or it can't do a 0 because it's dividing by 0, for example, then I don't want that to happen because that messes up the whole thing. So what you want to do is put some number like 5 or something here. Then we're going to say present value, the rate, that's what we don't know, would be pointing to this cell, which would have some guessed number like 5 in it, comma, the number of periods, which would be the 20 up top, and then comma, the payment, which would be the 5,500. Then enter, it would give us some result. That result, if it wasn't 60,000, then we can change by altering this cell. We can change this cell, and we can increase and decrease it manually, which would change the end result, and then we can tell Excel to do it for us using the goal seek feature, and then Excel can kind of back into that, and that's another way, once again, we can use what would probably be more likely to be used in practice, the present value calculation, to back in for any unknown that's within basically that function. So you can also do this with the tables. This is less likely to be done in practice, but a book problem in an attempt to remove your financial calculators or Excel or anything like that may ask you to do it with the tables. So in this one, it's kind of a problem because the answer is going to be, somewhere a decimal answer it. And remember, the limitations of the tables are that they're using whole percentages. Decimals don't really work, but you could approximate it, and a book problem could give you a problem that would work exactly into a percent, and you'd have to back into that. So if we look at this, we'd say, okay, well, there's 20 periods that we have up top, and so we know that on the table. We don't know the rate. We do know, if we look at our calculation, the calculation would typically be the 5,500 times the amount from the table would give us the end result of that 60,000. We don't know the amount from the table, but we know the 60,000 and the 5,500. So we can actually back into this 10.909. We could do that by taking the 60,000, which we know, divided by the 5,500, and there's the 10.9091. So once we know that, we can then go to the table and say, well, can I find that number on the table in the area that's for periods 20? So I'm going to go down to periods 20 down here, periods 20, and I'm looking for, so we have the periods 20, I'm looking for 10.909. So if I go back over here, it looks like it's between this 10.5 and then 11.47, and that's between 6 and 7. So we can kind of estimate the 6 and 7. Once again, a book problem could make it exact to be exactly between there. We have an answer that happens to be a decimal, the 6.63. You could use kind of a ratio analysis to narrow it down. But again, most likely, if a book problem was to force you to use the tables, then they'd probably make it an exact percent. And note that you can use the tables. You might think that you can't. You might think, well, I don't have the interest rate. How can I use the tables? Well, you could back into the use of the tables by first calculating up top, and then finding that number to back into the actual interest rate with the use of the tables.